Hello, everybody. Thank you for coming. It's great to have you all here. Today I have a special privilege and honor to introduce, and I will try to get it right, Luke Brzozowski. Thank you. I did have assistance from our kind librarian who trained me how to pronounce it correctly. So Luke comes from Techna, where he leads a big enterprise there of over 50 people in his team, comprised of different engineers, software engineers, study coordinators, other research staff as well. Before joining Techna, he was a member of, again, different enterprises at a senior managerial level. Today, he will be talking about Techna, what Techna is. It's one of the institutes within UHN. And I was actually, Luke and I met through Transform HF initiative from Heather Roth's side. And Luke told me a little bit what Techna does, and I was quite impressed. So I'm like, okay, I think this warrants a THETA round for sure. So please join us. Before Luke starts talking, presenting today's presentation about Techna, we will also introduce ourselves. So Luke get to know us a little bit. So I will start myself. I'm Val Rek. I'm scientist with Ted Rogers and Peter Monk. I'm also associate director of THETA, and I teach at IHPME. And again, welcome. So
I'm Joanna Bielewski. I'm a research librarian here at THETA and also a moderator for today's webinar participants. And we have 7 people online.
Okay, perfect.
I'm Marina Richardson, a first-year PhD student at IHPME.
I'm Gavar Machan, a PhD student. I'm a PhD for media research.
My name is Richard. I'm also a PhD student from Sweden.
Okay, international.
I'm Wendy Unger. I'm a student of life, but I'm a senior scientist at SICKID, professor at IHPME, and director of technology assessment at SICKID.
I'm Laura, and I'm a first-year master's student at IHPME.
I'm Celia, and I'm a first-year master's student of Christine at IHPME.
I'm Lusna Bremen. I'm a supervisor at IHPME and clinical epidemiologist at THETA.
And our scientist PhD.
I'm Yeva. I'm a research associate at THETA and master's student at biostatistics.
I'm Rafael. I'm a postdoc fellow here.
I'm Lechita. I'm a PhD student here.
I'm Rafael, a research associate here.
I'm Leah. I'm a biostatistician from the BRU.
Julie, research associate at THETA.
Julie, I'm a biostatistician at the BRU.
Troy, I'm a research associate here at THETA.
We have 7 people online.
And there's someone at the back.
Oh, sorry.
I'm a PhD student.
Okay, perfect. Please.
All right, so thank you very much for this opportunity. At UHN, I wear several hats, but here I am on behalf of Techna, where my boss is David Jaffe, who also wears several hats, but here he is as the director of Techna. So we started Techna 7 years ago, from basically ground zero, not really knowing much what it is that we want to do apart from having some vision and some mission. So I will tell you how we have evolved, what it is that we do. Feel free to interrupt. If I know that I will be explaining a given topic later on, I will just tell you to please wait, but please feel free to interrupt me for any clarifications. I don't think I have to go through this because you are all familiar with UHN, that it's a very large institution. I just wasn't certain what the profile of the audience, but UHN is, large institution. What's important is that it spends a tremendous amount of research and development, around 400 million out of 2.1 billion, that it's its entire budget. And today there hasn't been much return on investment, so there hasn't been really much of money flowing back into UHN to keep capitalizing on our initial investment. And that was one of the motivators for why Techna was formed. We were formed with an initial donation from Carlo Tidani, philanthropic donation of 5 million to jumpstart us. And since then we've been leading of different projects, grants, philanthropy donations, and lots of industry collaboration. So what are we? Techna is an institute of UHN, so all of our employees and myself, all of our staff are employees of UHN, as I am, and we are dedicated for accelerated development and exploitation of health technology for improved health. We have a single metric of success, is whether a given technology is used for the benefit of patients. So we try to fill the gap and not compete with what existed before and what exists what exists around right now. We have academics that work with us, but we are more downstream. We usually work at the point where a given invention has been proven. There is a prototype and it has to be reduced to practice. So the people that work with us are very much oriented to have a practical implementation of what is happening. So we don't want to compete with University of Toronto investigators. We don't want to compete with investigators at other institutes, and we don't want to compete with the industry. However, we are a glue in between all of them, as we like to think about ourselves. As we've tried many different things over the last 7 years, we kind of narrowed down into a very broad topic, and it is that if you want to develop and integrate health technology into hospital environment, it's a very complex project. It's a very complex problem. And the technology development itself, while very complex on its own, is just one of the pieces of the puzzle. So of course you need sound science, you need proof of hypothesis, you need refinement, you need engineering to reduce a given invention to practice. But to comprehend the entire development, you have to also look at all the other aspects, so that when a given health technology is dropped into the ecosystem, there is the whole net of factors that can actually catch it and implement it. So you have to be doing testing in different environments for different health technology. You have to look at what are the workflows, processes, and systems. So can it connect to things that exist? Does personnel exist that can work with a given technology, or are you demanding from the health system to come up with a new job description, new function, which is much more challenging? What are the training requirements? What are the regulatory considerations? And all of this has to be considered, the earlier the better, because this affects the planning of your technology. Reimbursement considerations, a field which we think is very important, and actually a field where we haven't done a lot of work, maybe potential avenue for future collaboration with you guys. Quality control and documentation. When you're developing a given product, very few academics have time, resources, and want to spend time on professional management, professional quality control. We have people that can do it, assigned on project by project basis, therefore filling the need that others don't have personnel for and may not find very important. Intellectual property strategy, another very important consideration, not just to be able to monetize or license or transfer into the real world a given technology, but also because we are governed by some policies of UHN. So there are unfortunately ministered prices where people get down the road too far but not protected it, and therefore they are disappointed that things cannot move the way that they want in terms of patents, licensing, and so on. Commercialization channels, we hurt people and we help them to think about how we want to commercialize technology. If that's their goal, we can link people with companies with as many successes there. And then also funding strategy. It's always challenging to raise money for any development, but we are quite open-minded when it comes to working either with the foundations, working with the industry, doing either consulting work, co-development, or applying for grants, and then matching and multiplying them. So that's what we've been doing for quite a while, which is development and co-development. We've done it within the hospital. We've done it with other companies. We've done it with companies where they have inventions that we refine, or where we have inventions and we work with them to refine. So we've been pretty successful in this. And a subset of it, or a niche that we are presently starting to be quite active in, is even more downstream, which is validating and pilot implementation. So if there is a given technology which is developed, there can be a startup or a multinational, and they would like to test a given technology in a hospital environment. It's also very complex. We actually suggest that people, when developing any technology, they do it in partnership with the real environment, because that's the real testing. However, often, you cannot develop technology in each and every environment. So we get approached by companies which are, or young investigators or startups, which want to test their technology at UHN. And it's actually a very challenging thing to do, especially because of the lost policies and bureaucracy within UHN, but we've had some successes. In this case, again, in addition to the whole technology piece, one has to look at where is the funding coming from, because this affects procurement, what are the contracts, is there a conflict of interest, so is the person trying to bring in technology for personal gain, who's signing on it, was the hospital-specific culture, which is actually department-specific culture, even at UHN, given that we have many different groups, was the time and availability of decision makers and staff, was the operational structure of the hospital, so with which departments we have to work with, engineering, IT, pre-processing, was the governance during validation, so that people have proper data collected from the validation, who owns it after the pilot has been, after pilot implementation, security, privacy, and interfacing within the hospital. So what we try to do is be the glue, think about all the considerations that are necessary for co-development and are necessary for pilot validation and implementation, or validation and pilot implementation, and offer these services to the community, both to investigators from UHN and to the investigators from the outside. While doing this, we find it's a very mentally nutritious exercise. We have to learn to sort of speak all the languages of the commercial world, of the academic world, of the clinical world, of administration, of operations. And our people would switch from projects to projects upon completion, gaining experience and being able to do things better and more efficiently. So, in the way that we find that there are several key elements which are necessary to fulfill our mission or to keep doing what we are doing. We strongly believe that we need a professional technology development team, which is the team that Valerie has mentioned. We started 7 years ago with 3 people. Now we have 50, and we've grown purely by demand. So, one of the disclosures is that we don't receive any money from anyone to exist. We have to pay for rent, for all the costs, for each and every salary. So we've grown purely by demand, by offering our services to clients on the inside and outside. And therefore, we grew the skills which are actually required by the community. So we believe that such a professional development team is very much required in order to be able to do our work, and that very much complements the typical either academic lab or typical clinical operations or typical research operations. Another element is that in every project that we work on, we have clinical output. Sometimes we may not have a basic scientific output, but clinical input is necessary present in each and every project that we do. And we have a commercialization mindset. Commercialization here is maybe slightly broader term. It does not necessarily mean sell what we have done to someone, but it means ensure that that things are done with a mindset to spread it further, to spread it across the world. It can be licensing, it can be initial demonstration within the hospital in real environment, but we want to see it real and we want it to build some commercial value. So how we think we are unique. We are beyond research. We complement what others are doing. We are very well connected, constantly growing network of partners, and health technology for us is a broad term. It's hardware, software, and all the processes around it. While structuring how we work and while defining and redefining what it is that we do, we are in touch or have visited or have talked to many different institutes around the world. This is a pretty eclectic group, and they range from incubators for startups to more university-oriented academic groups, to parks which are offering services and housing large and small companies, to professional development teams, to a mixture of all of them. Yet the common themes of all of them and Techna is that they are dedicated to translation into clinic. They engage the triple helix, which is the industry, academia, and government. They're associated with major academic centers and teaching hospitals. And they are multidisciplinary and collaborative. Projects are driven by the clinical need, so it's give me a solution for something, as opposed to, see, this is what I've done, can you use it? And there is strong emphasis on project management in what we do, so professional execution of projects. And those are some of the key elements that we live by. The way that we are structured is that there are really three pillars of Techna, and the metric that I like to quote is that for every dollar of philanthropy that we have received, we are able to bring in $5.50 more into UHN. A portion of it, I would say 10–15%, stays within Techna, and the rest is spent on the cost of running projects in the wider community. So engaging clinicians, engaging other scientists, paying for other things. So we believe we have very high return on investment, and we invest into the community, not just into Techna. But the three main pillars is we have faculty, very limited, like literally 3 people, soon will be 5 or 6. That's because of, again, funding. But we have very wide affiliated faculty. So these are people from other institutes, either from UHN or other places, from other hospitals and from other universities. And with these people, we collaborate, we look for projects together, we define what are the next trends, we work together on a more academic side. But we also run professional projects together. We also have quite a lot of infrastructure. A lot of it was brought by us through different CFI grants, so I'll talk a bit more about it. And a lot of it was sort of transferred to us over years as Techna has been formed and then progressed. And that unfortunately, a typical lab or a typical bit of infrastructure which is used for health technology development is usually funded partially by CFI, maybe some philanthropy, beautiful facility, and over time it decays due to lack of operational funds, due to unprofessional management, and the initial investment is usually wasted. So we've taken a few of these under our wings. We try to run them professionally, and I think we've been doing a good job. And then there's the technology development team, which I've already talked about, which is the team that I proudly run. And those are the professionals, the engineers, quality control people, software developers, project managers, physicists, operational people, which help other investigators and companies to fill the gap that they don't have. So the gap that they have. In terms of infrastructure, we have our headquarters are actually on the UFD site in the Benson building. In the neighborhood, we are running a microfabrication center, so microfluidics. We have a large preclinical imaging testing laboratory, multi-million-dollar investment, constantly growing. A dry lab for prototyping, benchtop testing in imaging and robotics. Healthcare human factors lab headed by Joe Capazzo, as well as his Central for Global eHealth Innovation. A large molecular imaging program with cyclotron, radiochemistry lab, and PET-MR facility. An operating room for testing new technologies and new procedures using imaging, and MR-guided radiotherapy facility across the road. So this was the second pillar that I talked a bit about, faculty as well. And then the technology development thing that I talked about is what we do is that we lead, manage, and carry out health technology, productization programs, and projects in a hospital environment. So we develop technology, we validate it, and we help with implementation. As we've been, initially we started as, thinking we should be doing engineering and coding, but as I said, in time, we've grown our offerings to the community to quite a wide range of services. so that we can cover the entire productization process and fill all the roles which can sometimes be surprising that they exist. So in addition to just developing the technology, we engage key opinion leaders. We do it for internal and external partners. We do lots of technical project management, and I like to differentiate between technical and non-technical project management, which is that our project managers are not just Gantt chart and budget, but actually understand the technical problem. So they have background which makes them able to advise on the technical development of a given project or program. They have much more respect for clinicians and for others, and it's more fun, and they are growing intellectually as well because of this. We do preclinical testing, we do all types of engineering and software. Software development is anything from electronic data capture to more physics-oriented radiotherapy or imaging guidance, validation, verification, human testing, human factors testing. And we've also started lots of work in clinical and regulatory affairs. So we can put projects or programs or groups onto specific quality control systems, which then make implementation of what they have developed much easier into the real world. So when a given project is finished, it's packaged from the regulatory standpoint in such a way that the company can receive it and implement it much easier, as opposed to have to review the entire documentation. So we've worked with JDMI, we've worked with CCRM, we've put several startups on it as well from the neighborhood. We work on some submissions to Health Canada, and we also run our own imaging core lab, which is a service which is available to actually globally presently, where people send us images from multi-center clinical trials. We anonymize them, we do quality control, we anonymize them before they are sent, we store them, we offer them to the investigators for analysis. We have a marketing team, which we use both for our needs, for marketing of Techna, but we also offer it to the communities, a group of 3 very busy people, anything from websites to branding, to hosting services, to recording. The small accounting team, because we expect financial oversight at a much higher level than what unfortunately the institution can provide. So we run our own money while being subjected to their rules. Some work in knowledge transfer, and already talked about managing the productization facilities. Where we are in terms of technology, before we try to define more fields, more pillars, more rigid, I don't think it really makes sense, as well as I don't think it makes a lot of sense to plan your technological roadmap for many years ahead, because things are changing all the time, and you shouldn't be actually boxing yourself. So we have many programs, many projects, and they overlap as opposed to be, and morph constantly, as opposed to be rigid. So we have some work, in hardware and software, so to speak, work in mobile health. We like to think that what we are building is a big machine. So ability to collect as much as possible data from inside the hospital, apply analytics to it, and then pipe the findings back into the hospital for better context, to provide better context of care. In order to do it, we are collecting clinical outcomes. We have several projects there. I don't know if you're aware of it, but not many places with large rigor collect clinical outcomes. So often the work is done, and then there is no follow-up or no measurement really of how well a given population has been treated, which is, I guess, partially a consequence of, and here you know much more of our not really value-based healthcare, but more procedure-based reimbursement method. Growing work in data science and AI with already some successes, lots of interaction with imaging, and I also have a role at JDMI at the Joint Department of Medical Imaging, so that helps. Anything from molecular imaging in development of algorithms, management of trials, to more of the big data work, surgical navigation. So we were working with the Department of Surgery on devising new procedures, new imaging navigation, implementing into the operating room, new program in augmented reality, so projecting onto patients what's inside them while looking through either special lenses or flat screens. I'll talk more about it. Lots of work in radiation therapy, everything from the treatment planning to quality control to documentation, and we are always keen to have access to bills to help fundraise for large, either the operating rooms and test labs. We've worked with a lot of companies. This is a growing list. I think there are a few more logos there. It's everything from not-for-profits to small startups to large companies. The project can be $5,000, small key opinion leader collaboration to multi-million-dollar multi-year program on project on molecular imaging on building the MR-guided radiotherapy. So this keeps evolving. Often companies come back to us for refinements of what we have done together. We link people together as well. So now I'll give you some examples about the, I'm just checking the time, about some of the projects that we are working. So here is an example where we are working with a Swedish company, which has been a startup 10 years ago. Right now it's a multi-million, $500 million worth company. They're doing radiation. Initially, they started doing radiation therapy planning, so planning how the X-rays are applied during radiotherapy for cancer patients. And now they are moving more into informatics systems. So with them, we are working on co-development of an oncology information system, where one of the partners is Research, the company that we work with, and the other one is Princess Margaret Cancer Center. So we are using, with full endorsement from the Princess Margaret and UHN leadership, we are using the Princess Margaret as the test bed to design this oncology system in such a way that it works for us, and then they can take the learnings and adjust what they do at other places by saying that this is the model from Princess Margaret. What's good about it is that we will be able to keep it for free, and for 10 years we will not have to pay any service. So we consider it a win-win for everyone. And we are starting with the design of pain points, which are maybe not so profound scientifically, but are very important to the life of patients and to the life of our administrators. So scheduling, workflow, communication, the present communication between different IT systems at UHN and at cancer, which is super complex, is a mess. Systems, don't really talk to each other. I guess it's a natural consequence of the evolution of amalgamation of, understanding of people actually wanting to try new different things, but we are trying to streamline as much as possible. Lots of work on processing, lots of work on designing process and including all the stakeholders from nurses, administrators to clinicians. We are doing their process management and workflow definition while working with the company. The other thing is that we are structuring with Princess Margaret is the data science program. So this will be a multi-year program where that deals with data science at each and every step of the cancer journey. So from prevention, screening, diagnosis, treatment, and then hopefully recovery and survivorship or end of life curve. The basic way to define what we do there is we want to gather as much as possible high quality data, analyze it for trends, and then based on the trends, recommend what could be done differently. Multidisciplinary program, heavy involvement from both clinical and scientific part. Lots of structuring, lots of projects already on the go, and I'll give you some examples. But where we think that we as Techna can bring the most value, and this is another big learning, is we like to build frameworks that others can capitalize upon. So we like to prepare a clean ecosystem, a sandbox where there are defined rules and data are of high quality so that people are working with good tools. Underlying this is what are called FAIR principles, which is findable, accessible, intraoperable, and reusable. And this is how we believe, this is not our idea, but this is how we believe that data should be governed. So first of all, if you want to come up with good conclusion, data has to be findable. And while people are quite good in, or reasonably good in keeping data within their own lab for their own purpose, it's a waste. We should be able to share data with each other to, even though, I guess, but let me take a step back. Despite the fact that the patient data belongs to patient and all the other data belongs to the institution, in reality, the data belongs partially to the patient, partially to the investigator, partially to the institution, partially to the department. So there are all the politics of ownership, who receives money for what, why would I give my data to someone, which unfortunately limits the return of investment and limits the speed with which we can do, because often two people are collecting similar data and not sharing it. So at the very least, what we would like to be able to do is have data catalog, to be able to say these data exist in the ecosystem, and if you want to reuse it, talk to that person. So this is findable, findability, know what exists, what is the depth, what's the quality of elements, why was it collected. Then also it has to be accessible, which you can split into different ways. There has to be technology so that you can pull the data after you have permission, and there has to be a data governance framework, which means there have to be rules that define what you have to do in order to access data with full respect of patients' rights as well. Then it has to be interoperable, which is the I in the first principles, and that means that if you are gathering the data and you can think at the beginning or throughout to collect the data in a certain way, package it in a certain database, then it can be more easily used for another purpose. So an example of this can be that you are acquiring imaging data to analyze a given drug or for a clinical trial. When doing it, think about how to package these data so that they can be then used for more advanced radiomics or artificial analysis. And data has to be reusable, which is the term that means you should be able to find what was it used for previously, where it originated from, look at the history, because not only then you might be not wasting time to review what others are doing, but it can stimulate your imagination how data should be used. So one of the biggest Techna missions in the data science program would be to build just this. So if we can speak the same language, we can find what's out there, and we can reuse what has already been collected in addition to collecting new data. We want to build dashboards like this. This is an example. So this shows you for what diseases, from which diseases a given population has been suffering, what are their concerns. It helps you to design your prospective studies, or it tells you what data are available for retrospective analysis. There's some of the demonstration projects within data science. It can be anything from bioinformatics and computational biology to treatment planning and radiation therapy to in the right bottom corner, seeing how the patient-reported outcomes correlate with the actual outcomes for patients. So again, looking at different inputs, looking at outputs, not necessarily solving an equation, but doing more machine learning on the data to be able to predict what to do, and then giving it as a context to clinicians, as a context to administration. Another program where we've been active for quite a while, more in the two-dimensional domain, but now we're taking it into 3 dimensions, is augmented reality. So augmented reality, not to be confused with virtual reality, is, let's say, seeing the real world, looking at the room, but at the same time seeing things superimposed into it. While virtual reality is like playing video games with 3-dimensional goggles. All you see is the fake world. And there are many different applications of augmented reality, mostly in intervention, but also in things related to intervention. So for example, in neurosurgery, you can be superimposing features that are inside a human being during the surgery, and therefore planning go, no-go zones. In head and neck surgery, we've actually implemented inside the operating room, so far on a screen, but during the head and neck surgery, we can paint where are the specific areas that one should not be touching or one has to be aware of when planning surgery, and guide in real life while positioning three-dimensionally let's say, a scalpel or something that goes inside a human being. We have also superimposed images from an endoscope and then used it to better delineate features for radiation therapy planning. In orthopedic surgery, we are planning how to do osteotomy, so how to cut the bones, looking for best ways to access for the least damage and also to achieve what you want. Radiation therapy this is an example in closed surface lesions. We can be combining where radiation therapy is applied with white light and with fluorescent light, superimpose all of this in real time, combine it with CT for planning for navigation, and the same interventional radiology. As people are putting needles inside the human beings and tubes, we can guide where it is the lesion that they are. Rapidly evolving field, it can be done either with glasses or it can be done literally with holding your phone in front of a patient and superimposing features which are preloaded while looking, at the leg. The translation domains for it is everything from education to planning to intervention to review. So in education, it can be used for, looking at the hand movements of humans and then seeing how they should be moving, or recording how a very well experienced surgeon is doing something and then monitoring her or his hand movement against what the trainees are doing. Planning, you can use three-dimensional CT, X-ray, or MRI scan to come up with 3D print, and while looking through glasses, you can look at the features inside the skull when planning how to do the operation. Intervention is literally look at the human being and you can see what's inside the human being, how deep it is to guide yourself. And in review, you can record everything that was done, superimpose it with additional medical imaging, and analyze what you should have done, what went wrong, what could have been done better. And then all of this can actually be then posted into textbooks where you can look at you can look at the page, and with three-dimensional glasses or through a phone, things can pop up so that you can have a better learning experience. In order to be able to really do it well, we think that we should have a good test bed for testing our augmented reality and surgical interventions, and we think that the test bed should be an actual operating room. So with support from, I guess, all the top surgeons from UHN, so it's Schaaf, Galera, Barry Rubin, several others, we are starting a surgility program. Please don't blame me for the name, my boss came up with it. But what this means is that the present support in the operating room is clinical staff, maybe anesthesiologists, which is a clinical member of clinical staff, but there are no engineers there. So if something breaks down, like computer breaks down, then they can open a ticket. How good is this? Like how useful? Like, and what are supposed to do with their nose while being fully scrubbed? The same, there are medical engineers who are amazing at bringing new devices in, at checking what's going on, whether it could be connected. But we want to have something more of a SWAT team of engineers that works inside the operating room, that goes to the rounds, clinical rounds, listens to the cases, and first of all, learns what are the pain points, what it is that the doctors want and clinical staff, where something is positioned poorly, what should be the customer service. And then with this in mind, implement our new innovations, including augmented reality in the operating room. So it's a special phenotype of people that enjoy clinical work, that are good engineers, that don't mind spending long time in the operating room, and that are dedicated to the translation. So we just got a go ahead for this program. We hired 2 people this week. And this nicely combines to everything else that we are doing, because now we can take pre-operative 3-dimensional images. We can post-process, so make them look in, like, focus on the areas of the image that we want. do three-dimensional printing so that we can plan a given operation. Use augmented reality to look, let's say, inside the skull and look where the lesions are. We've just worked with Barry Rubin to bring the first real-time holography into the operating room. First case happened earlier this week, which is literally a patient laying on his or her bed, and the heart is levitating in the air, and you can rotate it. Combine all of these for better intervention, and then after the intervention, use it for analysis and training. So we hope that next year we will be pushing a lot of this. All the pieces exist. Tremendous amount of workflow development. Who comes where, which department you have to go to, how to ensure the images are uploaded, that they are stored, that privacy is protected, that security is not leaking, that nurses are comfortable with this in the operating room, that an engineer is on standby. Definitely not sustainable in the long term, but that's why we are doing it, to come up with a sustainable lean program. And when it will be working, we will likely transfer it to medical engineering and go after defining new process and also keep implementing new innovations. Here is an example, another example of what we have done, and here we worked with two multinationals, Varian and Imris, on designing a suite for radiation therapy with ability to carry out MR imaging during the actual intervention. So on the left you have brachytherapy, which is a way for treatment of patients by inserting radioactive seeds inside them. On the right you have a clinical linear accelerator, which is typical radiotherapy, and in the middle you have MR magnet. And none of these devices was created to be nowhere near the other. Magnetic field, ion, radiation, the RF frequencies. But we work with engineers, we work with clinicians, tremendous help from clinicians, we work with the companies, and right now it's actually working. So during the operation, you can bring the, so during the treatment or after the first fraction, before the second one, you can move the magnet into the rooms. I guess I should speed up a bit. Here are pictures from the GTX, so image-guided surgical suite. So this is during the actual surgery. There's ability to carry out imaging, look what's happening, whether you are doing what you are supposed to be doing, or bring in fluorescent equipment to test new fluorescent agents which are marking where are the lymph nodes for cancer. Here's an example of a very successful collaboration with a company called Elekta out of Sweden, where we worked on the enabling new imaging outside of a very fine gamma knife radiotherapy device for brain tumors. We did first in human testing, we did first with clinical design, lots of coding and image analysis. They did the entire build, regulatory guidance, and right now they are selling this device with royalties flowing back into UHN. Another device from radiotherapy, nothing is profound. It's relatively a simple concept, but very, very useful. So I'm not sure if you know, but when there is radiotherapy applied, so X-rays are used to treat cancer inside the human being, nobody is checking whether what comes out of the linear accelerator is what is supposed to come. Most of the time it is, but you don't know until it's too late if something went really wrong. So you plan you carry out the plan. You design very carefully where the X-rays are supposed to strike. And then most of the time it works well. By placing this device in the path of the operating room, and don't worry that it's opaque because X-rays don't see anything, they just go through. We are checking in real life whether what's being applied to a patient is what was supposed to be applied, and if it's not, then we flag and then we can stop. So this is selling around the world. Another quality control device, which is called Aqua, it's a database, connects to clinical linear accelerator, that's automatic quality control, as opposed to have to send people, come up with plans, who is supposed to do what, looks at trends and flags if something is likely going wrong with a given clinical linear accelerator. We spun out as a startup. It was acquired by a multinational about a month ago. We're doing lots of work in databases, in collection of outcomes. So here is something that is deployed across Princess Margaret Cancer Center, patient-reported outcomes on iPads, so that when patients go into the operator, or when patients come for a visit, they can fill out a simple questionnaire as to how they are feeling, if they are distressed. Summary of this is presented to the physician when they see them, and we are also using it to get statistics, and it's also a requirement from CEO. So it's just an easy way to, from the cancer recurrence area, to provide it to them. MedChart is an example of a local startup with whom we have a very good relationship. What they have done is that, not really being dissuaded by how difficult it is to innovate because of strict privacy laws, they get consent from a patient to collect his or her entire data. They combine it in a single place and make it available electronically. So we are working with them on piloting, ongoing as it speaks, of doing it inside the hospital. Because you're likely not aware how archaic present system is if you are a patient and you would like to get your information when you are leaving the hospital. There is a group of people who go into your data, look at the screen, do a screen capture, paste it into Paint, print to PDF, and then they burn it on a CD. It's absolutely archaic. These guys can get it electronically and do it all for you, and actually, rather than coming a few times and paying for parking, this is cheaper. A big program in cancer informatics, which is the foundation for the data science program that we are forming. We've been doing it for the last 4 years. The premise of it is to get as much as possible clinical data, give it to a clinician, and give it on an iPad or whatever they want at the point of care. Combine history, where were the visits, what were the labs, what were the imaging results. Ask the clinician to collect the outcomes so that we have something for analysis. Take this data, give it to researchers, combine it with pathology, with other analysis, use this entire rich set of data to then do retrospective analysis. It's been going for 5 years. The research part has been doing quite well. We struggled always with getting clinicians to enter outcomes because it's an extra 30 seconds of their time. So we are working on some incentives how to do it, such as creating an automatic note which will go into EPR so it saves time for them. THETA is a program that we are doing for the hospital to provide better health and save money. So I'm not sure if you're aware of it, but there is an institution of constant observer. So if there is a patient who is at risk of getting up and wandering around the hospital and potentially hurting oneself, the person sits next to the patient on a chair 24/7. Often this is absolutely required because there may be a need for restraint, but quite often all such a person needs is to be told, please don't get up, we're gonna send the nurse. So we are replacing 6 of the human observers with 1 telesitter who can look at 6 people. The moment there is a movement, there is an alert on the screen. It turns red and it shows you the contours of how the patient is moving. You can adjust the sensitivity. By touching the screen, it alerts the nurse responsible for a given patient, and nurse comes over. Lots of the patients actually find it less invasive. They prefer it. And there is a 2-way communication so that we can also always just calm the patient down when the help is coming. Deployed across all of TGH, we are presently deploying it to Princess Margaret and Toronto Western. Spark is a program we are doing with Marsh and the province of Ontario. And here we are trying, I would say it's not really innovation, it's innovation in bureaucracy. So we are trying to finally enable local investigators to tap into provincial data repositories. So the labs, imaging results, it all sits there, but people cannot really access it. So when people are getting new apps, they are really not rich in actual data of the patient, although these data exist. They're almost all advice and better Facebooks right now. So we are trying to clean these pipes. It's not easy. We are having some success, but it's mostly basically fighting with bureaucracy to let us cut through, but we'll get there. This is one of the cost optimization initiatives. So here we are working with CCO, and we come up with dashboards to look at the cost of procedures per procedure, per given surgeon, correlated with outcomes. Some surgeons don't like it, but we've been tasked to do it in order to analyze different trends and in order to be able to, I guess, potentially reduce the cost without an output, without negative impact on clinical outcomes. So if I can say, maybe let me go back here, what I think that we really contribute is that our technologies can have impact on patients much earlier because we do it inside the hospital. So in the interest of time, I'm not going to go through all the steps, but not only we can use the technology for benefit of our patients at UHN earlier, because if you develop technology inside the hospital, you don't need Health Canada clearance to test it, as long as you can clean the ethics and given a clinician feels it's morally justified. But the technologies that we make are tested inside the hospital, so they're much more readily adaptable by the ecosystem. And when I look at what we have done at our ultimate metric, is in 7 years, we've grown the team from 3 to 50 people, and our technology affects lives of almost 4,000 patients a day, and everything from operating rooms to management system to imaging labs to quality control systems, and it's spreading globally. It's actually easier to commercialize for us out elsewhere in the world than in Ontario, which is a bit of a setback, but all of them have been implemented inside the UHN, so at least our patients benefit. Less altruistic comment is that how do we survive, and I've alluded to it. So when we commercialize a given technology, UHN receives royalties for it. Royalties are used to pay for our faculty. So this balances itself. And the team is supported from pay-per-service. So when we assign someone to work on the project, we cost recover that person's cost. And this has propelled ourselves quite well for the last 2 years. We've been purely self-sustainable, and we're actually making money for the hospital by saving costs and by bringing large overhead. Here is some again, just financial metrics. We brought in 54 million into UHN so far, including 6 million overhead. The initial investment was 9.6 million. This was in addition to Carlo Fidani's 5 million. So we had 5.5 return on investment. We brought in 3.6 million in commercialization revenue. To run the team, I have to find about 4.5, right now for like $5 million in contracts every year. The revenue has grown quite well. Techna is actually responsible for 65% of the entire UHN commercialization revenue, just that little Techna. And I guess this is pretty much it. So if I can leave you with some thoughts, is that in order to translate technology, it's a very complex environment where EQ is as important as IQ, and the mundane elements of being able to talk to everyone, being able to fill all the forms, use the fellow security is just as important as the state of the art science and engineering. Okay, so thank you, that's it.
So I think we may have a time for 1 or 2 questions. So if someone has please go back.
So, we're living in the HTA world here, health technology. So I think a lot of us are seeing your presentation through an HTA lens. And, one question might be is, how do your technologies save the hospital money such that those savings can then be reallocated to improve patient care in other domains? Is that something that you look at or track?
So I guess an example of this is the actual telesitter program. What really complicates, I guess let me take a step back. When I look at drivers of technology, technology. There are many different ways you can chop it, but one of them is you can chop it into 3 different ways: better outcomes, better access, and better sustainability. In the present environment, no hospital administrator cares about the first 2 unless the third one is satisfied. So we try to do it. We will be doing more of it. We were driven much more by our, I guess, curiosity and outcomes driven. I'm a bit advocate that we have to do actually both, and we have to do more for saving money for the hospital. What does not help is the financial structure of the hospital, and in general of any paper procedure social system. Everyone is disincentivized to save money because they don't see it does not end up in their department. Why would I do it? So even if we save something, the last thing a given department wants is to market it, right? Because it's against them. It's like when you look at it, and you guys know it much better, so maybe you can even correct me, but if you think if a given patient costs $5,000 to stay in a bed, and then you provide $200 a day remote solution, then what? Then you have to pay for both because right now you get a second patient. So there is a disincentive unless you can provide money to the people who are innovating, and unless we move much more towards value-based healthcare.
Yes, please.
Thank you. How do you decide area of priorities for intervention to be addressed by Techna?
So I guess the question is, how do we select what projects we do? We do not have a very formal screening process, and I kind of like it. It's really as long as I think it makes sense, and I talk to several key opinion leaders, and I think we have skills or that we can acquire skills, and there is sufficient funding. So far, we've just done it.
We have a question from a person online. From James Bowen asks, excellent presentation. How have you incorporated randomized control trials into the program to evaluate incremental benefits compared to current practice and the associated costs for the intervention?
We do not. So we are not in the business of running clinical trials. We are in the business of collecting data from imaging clinical trials, and we have not been designing such things.
Thank you.
Thank you so much for coming.
Thank you for the opportunity.